Hi guys, and welcome back, and hello to the new subscribers, and hello to the current existing ones, and to all of my students, past, present and future. So this lesson we're looking at electrolysis, the basics of electrolysis, and then we're going to go into the electrolysis of molten ionic compounds. Okay, so the specifics of what we're learning about is we're going to learn about what happens to ionic compounds when they are dissolved or melted. We are going to look at the parts of an electrolysis cell. We're going to describe the process of electrolysis in terms of ions, and we're going to look at some specific examples of molten ionic compounds and the electrolysis of those. This lesson is fairly easy. There's quite a few facts to learn, but there's nothing that's particularly out there in terms of the concepts behind it. One thing I just do want to clarify is sometimes people are a bit unsure about the term molten. If something is molten, you've melted it. Essentially, to make something molten, you have melted it. So a molten ionic compound is an ionic compound that was a solid, and heat is being applied to it until it has become a liquid by melting it. So, what is electrolysis? Well, electrolysis is where electric current is used to separate the ions in an ionic substance into the individual components, and essentially it means electro for electricity and lysis, which I believe is Greek or ancient Greek for splitting. It means to split something up with electricity. Another definition that we need to know is we need to know that an electrolyte is a name for the substance that's being broken down, or the substance that is conducting electricity. Okay, so a liquid which can conduct electricity through ions is called an electrolyte, and we're going to look at that in more detail in a second. So, in order for electrolysis to work, the ionic electrolyte, that must be able to conduct electricity. Okay, this should make sense. Okay, so we're trying to split something up with electricity. We're trying to rip it apart. So an electric current's got to be able to flow. If there's no electric current flowing, this can't happen. Now, we've said this is going to be working with ionic compounds. Now, solid ionic compounds like table salt, which is also known as sodium chloride, chemical formula NaCl, they don't normally conduct electricity, and you should have done experiments about this in school. So a solid ionic compound doesn't conduct electricity. Okay, there's no way for it to conduct electricity, so it's an insulator. In order to make electrolysis work, then, we've got to make these ionic compounds able to conduct electricity. And there's two ways we can do that. We can either melt them or dissolve them in water, or in any liquid that they will dissolve in. Normally water. Okay, so when they're molten or when they're dissolved, when they're in a liquid state, they do conduct electricity, and therefore they can be used as an electrolyte in electrolysis. So let's have a closer look at molten undissolved ionic compounds. So when the ionic compounds are melted or dissolved, the individual components, the individual ions, separate and start moving around, or they're able to start moving around. So for example, in sodium chloride here, we've got Na, sodium, Cl, chlorine. When we dissolve it or melt it, these break apart. You can imagine they crack apart, or they get pulled apart, and we get two ions. So you should know group 1, this is a bit of revision from topic 2. Sodium is a group 1 metal, so it's going to have a +1 charge, and chlorine is a group 7 non-metal, so it's going to get a -1 charge. So they're going to separate into their ions, an ion being an atom or a group of atoms that have got a charge on them. So they're going to separate into their ions and start moving around. And because they can move around, and because they have that charge, they can conduct electricity now. So this is our first step in electrolysis. Okay, so important part to take away here. The first step in electrolysis, the first important part is we've got to either dissolve or melt an ionic compound. Now, when we do electrolysis, we set it up in a little bit like this here. Okay, so firstly, we've got our beaker with our either dissolved or our molten ionic compound in the bottom. And this is called the electrolyte. That is what we're going to do the electrolysis on. Okay, so we can say it will be electrolyzed. We have a power supply here, and the power supply we have something called a cathode. The cathode is the negatively charged electrode. The other electrode, an electrode is just something that gets inserted into the electrolyte and can conduct electricity as well. The other electrode other than the cathode is called the anode, and that is going to be positive, so they're oppositely charged. And this is important, and we'll talk about that in a second. And then we have a direct current power supply. It has to be direct current. That's an important part as well, direct current power supply. And that provides the electricity flow. So the electricity can flow, the electrons can flow down into the electrodes through the solution using the ions that are dissolved in the solution. And we're going to look at an animation for that in a second. Now, a way of remembering which electrode is which you will be expected to know, is panic. And that's a little an acronym for positive anode, negative is cathode. So make a note of that. Make sure you learn this. So positive anode, negative is cathode. And that tells you what charges are on which electrodes. Okay, so here we have some electrolysis of molten sodium chloride, table salt, the same salt you put on your fish and chips, and the same salt that they spread on the roads to stop them icing up in winter. And we can see we've got the electrolysis cell here, and we've got our positive anode, and negative is cathode, and in the solution we have some chlorine and sodium atoms, or ions, sorry, because we've melted the sodium chloride and the sodium and the chlorine have split apart. Now, when we turn on the power supply, which might be a battery or it might be a power pack, when we turn on the power supply, you can see that the negative chlorines move to the positive anode and the positive sodiums move to the negative cathode. Opposites attract. Another example. We've got zinc chloride this time. So zinc chloride would be ZnCl2. That would be the chemical formula for zinc chloride. And we've melted it. And again, we've got a positive anode, negative cathode. And the zinc and chlorine ions are free to move. So the positively charged zinc go to the negative electrode. There we go. And the negatively charged chlorines go to the positive electrode. And there they all go. Okay. So far, so good. Electrolysis is the breakdown of an ionic compound when it's being melted or dissolved. The positive is called the anode and the negative is called the cathode for the electrodes. And the positively charged ions are going to go to the negative cathode and the negatively charged ions are going to go to the positive anode because opposites attract. Something to be aware of. Metals always make positive ions for GCSE. And non-metals usually, or almost always, make negative ions. So this is what you'll always see in any example of a question. It might say in the GCSE question, it might say, what will be formed at the cathode? And you can go, okay, panic, positive anode, negative is cathode. So at the negative one, what's going to go to the negative one? It's going to be the thing that's positive, because opposites attract. Metals are positive, therefore it must be the metal. And that will help you out there. Last little bit, ions also get attracted to the oppositely charged electrode, because opposites attract. 3 key points there. Now, the next bit of learning, which we've not covered in those animations above, is that when the ions finally reach the electrodes, they are discharged, what we call discharged. And you might have come across this before in your life. If you say, I'm going to discharge the static on this thing or like for whatever it may be, it means to get rid of an electric charge. So they either gain or lose electrons at the electrodes to get a neutral charge. So the positively charged ions, they're going to gain electrons at the negative cathode, and the negatively charged ions are going to lose their electrons at the positive anode. Now, little task for you to do here, and you can put the video on pause, thinking about what I've said about metals and non-metals and the ions they form and the charges on the positive anode and the negative cathode. See if you can work out what is going to be in each of these boxes. What's going to form at the anode, what's going to form at the cathode. It's really, really simple, but a little clue. There's two ways of putting what's going to form at the cathode. One's slightly more correct than the other. Answers time. Right, so we know panic. Positive anode, negative is cathode. We also know that metal ions are always positively charged, and we should be able to recognise the names of the metals from these compounds. That's really, really easy. So if we know the name of the metal, and we know that's going to be positive, and we know the cathode is negative, and we know that opposites attract, we can say, for the first example, that sodium will go to the cathode. Now, what will be formed at the anode will be from whatever's left behind in the chemical. We've used a sodium, so we're only left with the bromide. Now if you put bromide in as your answer at the anode, that's okay. But what we'll actually find being formed there is bromine. Okay, so it will lose its electrons, the bromide ions will lose its electrons, and it will pair up with another bromide ion to form bromine. The pattern carries on, so we get potassium iodine, we get calcium and fluorine, we get oxygen and magnesium, to do it the right way around, and we get chlorine and lithium. Okay, fairly simple. Now, the next thing we need to look at is we need to look at what happens at the electrodes in terms of oxidation and reduction. Now you probably have heard the terms oxidation and reduction. So when a compound is oxidized, it has oxygen added to it. When it's reduced, it's had oxygen taken away. Now it turns out that whereas that's fairly useful, it's a bit too simplistic for most of chemistry, and there's a lot of reactions that go on that could count as oxidation and reduction reactions that have nothing to do with oxygen. So rather than rename them for some reason, they decided to just change the definition. And the definition can be remembered with this phrase, oil rig. Okay, oil rig, and this is again something you need to learn. What oil rig stands for is oxidation is loss of electrons. So O for oxidation, I for is, L loss, and then in brackets of electrons. So oxidation is loss, and therefore reduction is gain of electrons. So you do need to know this. So oil rig. Now, here's an example. We've got lead bromide. We've melted it down. We've got our lead ions, which are the positively charged red spheres, and we have our bromide ions, which are the negatively charged blue spheres. Firstly, where are the lead ions going to go? Correct. They're going to go to the cathode, which means the bromide ions are going to go to the anode. Now, the next question is, when they get there, they're going to do what thing beginning with D? So good, I hope most of you got that. It's discharge. They're going to discharge. They're going to get rid of their charge. For something positive to get rid of its charge, it can't get rid of the positive charge because the positive charge on an ion is in the nucleus. It's on the protons, and it can't get rid of or gain any extra protons. However, it can gain or get rid of electrons because the electrons live on the outside of the atom. So when the lead ion hits the cathode, some of the negative electrons in the electrode go into the lead ion and they balance out the charge. So the lead is gaining electrons. The bromide ion, when that hits the anode, it wants to get rid of its negative charge. Again, it can't gain any protons, but it can get rid of the spare electrons it's got because that's essentially what's going on here. The lead doesn't have enough electrons, so it's positive, and the bromine has too many, so it's negative. So when the bromine hits the anode, gives its electron to the anode, and therefore we can use oil rig to work out what's happened. Okay, so at the cathode, the lead, which has got a charge of +2, it gains electrons to form lead metal. So if it's gained electrons, we used oil rig. Reduction is gain. So it's gained electron, so it is being reduced. The bromine, the bromine loses electrons at the anode, and again we go oil rig. Oxidation is loss, and then it forms bromine gas. So it must have been oxidized. Okay. Quick little summary then. Cathode is negative, anode is positive. Positive ions get attracted to the negative cathode, negative ions get attracted to the positive anode. Reduction happens at the cathode because the positive ions gain electrons, okay? And that's our discharge because it's losing the positive charge. The oxidation happens at the anode because the negative ions lose electrons. Okay, I hope that was informative and you found it useful. If you've got any questions, please leave them in the comments below, unless of course you're my current year 10s on the lockdown, in which case send me a message in Teams. Please remember to subscribe and to like the video. I look forward to reading your comments, and I look forward to seeing you again in a future video. Okay, bye bye.